Hello, my name is Alysha Helmrich, and I am a sustainable engineer studying how infrastructure managers can create more resilient infrastructure by expanding physical and institutional capacities. Biomimicry is the emulation of nature and design, and Life's Principles allows emulation at a systems level. This is important because infrastructure is also a network. In this module, we will be exploring the alignments, contradictions, contentions, and gaps between Life's Principles and resilient infrastructure core concepts. While this module can be viewed independently, I encourage you to watch the preceding module. Overall, infrastructure resilience theory frequently aligns with Life's Principles. However, infrastructure resilience in practice does not align and at times contradicts Life's Principles. To aid us with this exploration, we will use the table on the screen. All Life's Principles are represented in at least one core concept. We can see this by the green fill across the table. Core concepts of resilient infrastructure found in practice were more likely to see contradictions to Life's Principles, depicted with orange fill. If a relationship between a life principle and a core concept could be interpreted as an alignment or contradiction due to the sub-principles, it is marked as a contention, or with blue fill on the table. Lastly, the white fill indicates gaps between these two frameworks. Now, let's learn how each of the Life's Principles can aid infrastructure managers in designing resilient infrastructure. First, evolve to survive. This principle is heavily represented in infrastructure design because infrastructure is designed not to fail. Survival, or service of infrastructure, is the primary measure of success. Engineers are well equipped to implement designs that have worked in the past, one of the sub-principles represented here. However, this does assume stationarity, that the future will resemble the past. Therefore, one major takeaway from this principle is the ability to learn from failure. Design approaches that embrace this are emerging, such as safe-to-fail infrastructure, where the infrastructure is also planned and managed for a failed state. This could be a park that provides recreation most of the time, but also serves as flood mitigation during rain events. This flooded state could be considered a failure since the recreational services will not be in use, and existing infrastructure may break. However, this is seen as a management strategy when considering the whole city as a system instead of just the park, emphasizing the importance of a system of systems design. Second, adapt to changing conditions. One way engineers currently prepare for changing conditions is to integrate redundancy into their system. For instance, a power company will set up more than one pathway for electricity to move between the generation station and the end user. This way, if one power line goes down, the company can still maintain service to the customers. Redundancy is an aspect of resilience also found in natural systems. We can find other potential solutions for adapting to changing conditions, such as integrating multifunctionality into infrastructure design. Think of your skin. It does more than protect your body. It also allows your system to sense and heal. Our infrastructure can also serve multiple purposes, such as the safe-to-fail recreational park and flood mitigation example just provided. This allows us to challenge what failure is. Is it only when the technological system is failing? What about the social and ecological components as well? Third, being locally attuned and responsive within nature has previously provided inspiration to infrastructure design. For example, industrial ecology, xeriscaping, and passive design. However, current practice shows one large contradiction: robustness. Being locally attuned and responsive emphasizes the importance of cooperative relationships between infrastructure and the surrounding environment. With innovations of canals, railways, service lines, and heating and cooling ventilation systems, humans have further disentangled themselves from nature, attempting to survive independently from the surrounding environment. Now, infrastructure managers do not need to devolve, but should actively consider leveraging cyclic processes, readily available materials, feedback loops, and cooperative relationships to increase resilience. Fourth, integrate development with growth. Natural systems do not design with an overarching blueprint, but through modularity with components evolving in conjunction, from individual species to communities with co-evolved members to complex ecosystems. Resilience emerges over time from the collective properties of the ecosystem component. Integration of development with growth rivals the lock-in or inability to change a system due to financial, political, technical, social, cultural, technological barriers that is oftentimes seen with infrastructure systems. Infrastructure does not currently have the capacity to co-evolve with social, ecological, and technological systems due to this lock-in. In short, as long as infrastructure is designed in a stationary manner, the system cannot be perfected to a surrounding environment because social, ecological, and technological systems are constantly changing. Fifth, be resource efficient. Infrastructure managers are very good at this. Infrastructure design seeks to reduce the resources and energy used to minimize costs. This is represented in sustainability efforts. However, sustainability, commonly understood as reducing negative environmental and social impacts, does not promise resilience. It is simply one aspect, as shown in LIFE's principles. For example, LEED certified buildings, while effective at promoting sustainability, do not necessarily increase the resilience of the design. One thing infrastructure managers can consider here is satisficing instead of optimizing. Satisficing is a combination of the words satisfy and sacrifice, meaning you have to address the trade-offs from a social, ecological, and technological viewpoint, each appropriately. Sixth and last, use life-friendly chemistry. Now, this may seem irrelevant for infrastructure design, but this principle reminds us to build selectively, not using unnecessary or hazardous materials, as well as through modularity. By following these guidelines, the complexity of a project can be reduced, which can allow easier management by combating the convolution of legacy systems, where future managers may not understand or have the tools necessary to fix the system. All in all, LIFE's principles can help guide infrastructure managers toward more resilient infrastructure. The objective is not for every resilient infrastructure core concept to address every LIFE principle and sub-principle, but that the infrastructure design addresses each of these principles through an amalgamation of the resilient infrastructure core concepts. LIFE's principles offers a snapshot of design lessons and strategies that have emerged and sustained life over 3.8 billion years in the face of dynamic and often unpredictable operating conditions, which serves as an excellent role model for infrastructure managers and resilient design. Thank you.